Good morning. We have the Casper collab and computational calculus session this morning. Uh, Gary and I showed up early. Thomas Love showed up late, and uh, we were investigating the the putting the art objects onto our chain and looking at, in Ethereum for inspiration of how to create proxies for these works of art that we can manage the capabilities of. Um, uh, Eric, has been doing the blockchain stuff. I don't know if you can ping Eric if you can join. Can you ping Eric, Gary?
Yeah, I don't think he's available on Fridays.
Yeah.
He's never showed up on Fridays, but I'll ping him.
Hey, and we don't have to do this today. We'll see what else you have on your mind. I just wanted to bring you up to date as to where we are. So we were looking at the 721 token, which Eric has sort of looked at as a basis for an art object on Ethereum.
Oh, I see.
And
I'm not familiar with this token.
Yeah. Well, it's basically, and as I understand it, all these standards that we're looking at, or standard interface we're looking at, were sort of designed by this guy who did the ERC20 interface. And some very interesting justifications and discussions about, why these interfaces are good. Now we're using a different security model. We're using object capabilities. So this stuff may or may not apply to us. We have to change it to a new context of the electronic rights is where we're trying to go with these things. We want the art objects to essentially be blockchain agnostic. Our first implementation target is art chain, but they should run on, we should be able to run, put them on Ethereum or any other blockchain we want as well. Let's see, and we want them to be mobile to some extent. So, maybe for some reason one chain gets corrupted, we want to move the objects to another chain or something. We need to be able to do that kind of thing.
Yeah, or store it in the multiple chains, right?
Right.
We're
in mobile, but I mean it has to be coordinated. You have to have the cross chain Milner's cross chain contracts.
Yeah.
So looking at this, and then I guess right at the beginning here, we come up with the idea that we have to have an identity. We have to have an address, and in looking and on Ethereum, we have the ERC 725 and 735, which is the standard interface for a simple proxy account. this is this is the identity standard actually. In that, the proxy is what gives you capabilities, keeps information about the object, and gives you access to the capabilities of the object. And this is the non-fungible token aspect is just the idea of negotiating transfers of ownership. And you know, that's where we can implement the
So in the case of ArtChain, identity is some kind of unforgeable name that is protected and related to one or multiple public keys, like key pairs, right?
So for example, the artist reserved rights transfer and sale agreement can be part of the behavior of the non-fungible token. The token, who owns the token owns the object, and how it gets sold or whatever is determined by an agreement that's part of the behavior of that token in some way, which we're coming up with. And the artists themselves and the art object have a proxy, which is there's two interfaces. The ERC25 is the interface to the object. The ERC 735 is is basically what we implement in the object. Or
do you have some summary about that? So I don't know what these tokens and how they work. So can you give some short info?
Yeah, go to that 735 page.
Is this means that each art object creates their own token for this art object, right?
Yeah.
Okay.
Yeah.
Okay. And this created token is based on these two tokens that you mentioned, right?
The idea is that anything that can be anything that can support the 721 interface. 721? Yeah. So
Go to that. Which
can be put into a trading system. Okay, that's all. Okay, because it supports the standard interface, and it's for physical property, houses, unique artwork, or virtual collectibles,
or negative value.
negative value assets. Okay,
Like,
so this allows you to have a marketplace. Basically, it's just the basic raw capability you need to put things into a market. You want to do that in a standard way.
Oh, I see.
Okay.
Oh, cool.
So handling non-fungible tokens is independent of what we're doing, but that's what we need to have some way of doing that in our chain, right? And some corresponding interface. That's how we do it. Okay, and then
when you say proxy, you mean proxy that creator of the token can make some rules how this token is distributed, or is this the word proxy that you mean, or?
that's the idea, but the proxy, I think, is a more fundamental step in the process. Right, Jim?
Yeah, well, it's just a standard interface. I mean, it's what I would try to do with my object.row.
Oh, I see. I see.
A standard way of talking to another object.
Like proxy to rholang, proxy to Ethereum, right? Proxy to different networks.
And you know, have the concept of ownership and have metadata, essentially key value store. You know, what this does is it's a proxy object. It can execute arbitrary contract calls, and it can hold arbitrary data through generic key value store. So it basically, and the way that this works in Ethereum is it you know, it gives you get some signed code that someone else has given you, and basically they've given you permission to run it. So when you execute that code, well, you pay for it, and it gets run as them with their permissions or their context. I don't know exactly how we do that. That was one of the things Gary and I were hoping somebody would come on to help us with.
You mean in the how on the Archain or?
Yeah, I mean, okay, so you know, we can call something with the delegate call, we can do create, and this is inspired by the ERC 1077.
Share your screen, Jim.
Oh. That would have helped quite a bit if I had shared the screen, I guess. What was I showing? Yeah, this was the 721 non-fungible token. And then we have the, okay, 725, which you have a key value store associated with the method, and you can execute something on it, either with a call, a delegate call, or create, and we can look at that, and that's inspired from the 1077, ERC 1027, and the Gnosis, which I have to look up again. You know, the Gnosis wallet is a multi-sig wallet is what it is. And executable signed messages refunded by the contract. I have to look at that a little bit, but and you know, and these are the issues that it's set out to solve, you know, address, which are issues that we should need to address for our chain. Users don't want to think about ether cost. Users don't want to think about backing up private keys or key phrases. Well, with the capability model, we don't have to worry about that too much. Users want to be able to pay for a transaction using what they already have on the system. Apple Pay, Xbox, using credit card. Users don't want to sign a new transaction at every move. Okay, I think that's an important one. I mean, you know, certainly in implementing the user agent or the proxy, you know, the proxy has to be able to sign for them. Proxy has to be able to, you know, that's the whole point of having a proxy. You don't have to actually be there to do something, right?
Yeah, so I'm thinking this in terms of very similar to multi-sign contracts, right?
Could be
You
application.
you, you provide your own signature, and you have another party with this proxy has another signature, so you can sign something in advance, and only when the proxy signed the another signature you can proceed. So and this is exactly what Mike is doing now.
Mike, stay.
Mike, stay. Yeah, and the first solution was to have very similar thing as solution with one signer. So you can generate a ref address from public key, but in case of multi-signature, you will not be able to do this, right? You will have an unforgeable name for signature. Something is missing.
Yeah, Gnosis stuff.
But I wanted to ask you, use this part of description was you don't have to sign everything, every move, and you don't have to think about private keys. How do you? I mean, you need to think about private keys. I'm not sure how can you skip, and not think about private keys.
So that link is wrong.
Go to Gnosis.io.
Oh, I found it.
Oh,
Right. You can see it, right?
well, I'm on a different screen. Hold on.
Gnosis contracts. I didn't get specifically what they wanted, but I think that's close enough. And this address is wrong. So what I should do is it should say I want to modify this thing. We really got to get in the habit of doing this stuff,
Go to github.com/Gnosis. That's the super page for all the Gnosis projects.
Yeah, I'm just going to fix this link so rather than specifically that file to go to the directory. So giving it context, I think, is good. But they may not broken link. Maybe I should say fix. Okay. We all have to be good collaborators, cooperators.
Yeah.
And when we see something, we have to say something. I guess I have to hit create pull request too. Not that other people couldn't use Google or find the answer themselves, but I think it's interesting that
So how do you imagine this working without private keys? So the proxy will do all this other stuff. Hi, Isaac.
Hey, how's it going?
No.
hey,
Showed up just for the last minute.
Well, we've got another hour, Isaac.
Yeah.
we actually are just getting started. Okay.
Oh, okay, cool. So I'm right on time then. Great.
So yeah. So I mean, what we're looking at, maybe Thomas Love was late, so I was bringing him up to speed on what Gary and I were looking into, and basically going back from the art on the the art on the blockchain project, we were looking at the non-fungible token standard.
Mm.
Basically, we could put these art objects on a standard marketplace,
Mm-hmm. Mm-hmm.
and thinking, well, for our chain, we should have a corresponding interface, right,
Mm-hmm.
for our non-fungible assets.
Yeah, is there a plan for anything like that so far for our chain?
Not that I know of.
Oh, okay.
I was hoping one of you guys would know.
I certainly don't know,
Thomas?
or at least I haven't heard of anybody talk about something like that before.
And maybe we can do this all inside the browser and use our chain network as the database, because we okay, for bigger objects this maybe is the problem, but we can definitely store the smaller objects.
Yeah, the non-fungible token is the critical part. We can store the art object anywhere we want to, but it's associated with the non-fungible token.
Yeah, I mean we can create this kind of token on our chain, right?
Yes. But we wouldn't want to store the whole art object on the chain, and we don't intend to.
Yeah.
Oh, we want to be free to specify an art object anywhere in the world or whatever.
Yeah.
I mean, ultimately, we want to be able to specify any object, not just digital object.
Yeah, and we can't specify where the artist is going to work. Right?
But we will have some kind of hash or multiple hashes of this object.
Yeah.
We can and we can store these hashes and reference it with this, but we can also store the whole object if this is.
If we want to, yeah, if it makes it
Yeah.
better and if it's small enough and if we want to pay for it.
Yeah, yeah.
Okay, and this led us to the idea that we need to be able to specify an actor or an owner of the of the object. And how do we do that? Well, we have the interface standard for identity on Ethereum is the ERC 725 and 735 standards, and this defines it in terms of a proxy object that represents the thing that we're identifying. Okay, we can keep a key value store of metadata about the thing, and we can execute methods on the thing, so it gives us capabilities. Now, in the 725 here, I'm not sure exactly what the limitations are in terms of what capabilities we can pass and how that works. Where are we?
But when you say identity, all of the identities must be protected with private keys, with key pairs, right? At the end, I mean, this is the only way you can authenticate. Right? You have your own key pair, and you doing the changes of the state in a way that you sign your piece of code that will execute on the network, right? So I see identity very related to this key pair that you generated and that you're executing your will, right?
I'm looking at identity in terms of object identity. Okay, not
okay.
not
Oh,
theory account. the Eiffel Tower. Okay, that's a identity. Okay, so you could have a 725 reference to the Eiffel Tower, and you might have certain capabilities. Maybe you have permission to open the door, so you would have an open the door capability that you can get from this. Well, first of all, non-fungible token, because that gives us a notion that this is the Eiffel Tower. It's not a copy of the Eiffel Tower, or a representation of the Eiffel Tower, whatever. Okay, and then the capabilities you get is through the 725 interface. So we have some comparable interface that we have to design for our chain, right?
Yeah.
And that's in the 725, 735. One's client server type interfaces. I have to look back at those. And this, why am I?
So this capabilities it's a sense similar to this multi-signature, right? Because I see this as a way to create conditions that you're giving someone else this way to execute something that you already that you are also confirmed, because you need to create the conditions that someone else's key pair can do something, right? So you first do your own part of the commitment, and then you say, okay, now your word it will exactly do the action that you want, right?
Yeah. So on Ethereum we have. Oops. Wait. Didn't I already submit that? No. I don't know.
So I thought this object capability stuff is where the unforgeable names really come into play.
Yeah, and this is how Revolt is working. If you have multi-signature, Revolt will be created with unforgeable name, not with Rev address, but with unforgeable name. So other contracts can also use it. And Mike is also Mike Ferk also wrote the another way of doing this. He wrote like a system process that you can generate Rev address for multiple public keys. But this is not what we want. So now he has another implementation that only with unforgeable name you can create multi-signature.
Oh, okay, cool. So it seems like in this case, though, when we're talking about like giving a specific person access to specific object capabilities, you almost need some sort of mixture of something like a private key with something like an unforgeable name. You know, like the person whose private key corresponds to this public key, they have access to this particular name, so that, like, you know, like Jim said, basically, like if someone access to be able to open the door of the Eiffel Tower, well, you also don't want that person to be able to give that access to other people, right? So it would be like almost a pair, like this unforgeable name and private key, or I guess public or private key.
Yeah, and in this multi-signature contract, you are providing two public keys that that is related to this unforgeable name, which is your wallet. So in that sense, you need to provide. You will have users or key pairs that are allowed that are allowed to give you this object capability, right? For your public key, for your key pair. So this is how I see it.
Yeah. Okay. Yeah, that makes sense.
So yeah, because at the end, you always want someone to confirm action with private key. I don't see any other way to do it.
Right.
because you're assigning your deploy with private key. So this is the way how now Archain is working. So you have deployer ID as a signature of your deploy. So
All right, but
Yeah.
you could, in theory, you could take a signed transaction and you can run it anytime at a later time, which is what they're doing here, really. They have somebody sign a transaction so that it can be called later by someone else.
but this is when you sign something, you want to execute only once, right? So you can execute it later, but
Well, that's why you have a
this is
nonce,
not.
right? So you have a nonce, so you can't replay.
Yeah, and now the nonce will be introduced again in Archain. So but you know, with the nonce, what if I give 100 object capabilities to 100 people, right? So I can give different nonce for each one, right, with different signature. So if the last one execute first, all the others will be failed. So I don't see that giving the whole deploy is the way to go. I think that you need to specify somewhere public key and say, okay, I give right to this public key to execute this. So this is how I give object capability, not by giving the whole deploy. I don't see that whole deploy can be used in this way.
I mean, it would be great if somebody could. I mean, you know, like. I mean, initially we took the ERC-25 and, you know, making a crack at a coin interface for Archain. I think it would be instructive to do something similar here. I don't know how to do this, but
I think we can use the same technique for multi-signature that Mike is now doing. I mean, we will just replace rholang actions with our custom actions, and that's it. And this is really the intention of this multi-sig, to be as an example to like these kind of contracts.
yeah, but you know, and this, I guess this is what Dan was complaining about too, is he couldn't get he couldn't figure out how to get a contract to
with connected to unforgeable name. So there is a way to create a vault from reb address, but also from unforgeable name. And this creation from unforgeable name, this will be used in multisig. And this can also be used for operation from contracts.
right, and you know this is, I mean, the Gnosis multisig is was one of the things that inspired this identity interface. But I don't know if you saw this, Isaac, but this was sort of our justification here. Users don't want to think about ether to avoid having to, I guess, always use the keys in the private keys.
So
how do you have a proxy object act on behalf of a user without them having to sign the transactions?
Yeah.
Right?
But you initially must sign something, right? Or how this works?
Initially, you got to sign something, but
so this can be like one signature of two needed signatures, right? You sign one signature, and this gives ability to this other private key is inside the proxy to make all the others, all the other object capabilities. And you can also implement that you can revoke this permission for this other key pair. And
That's it. Yeah, that's interesting too. It has to be revocable. But basically, on Ethereum, they have the requirement that you've got to be the owner of the proxy object in order to get permissions
Yeah.
from them. Whereas with the object capability model, we just only the owner is the one who has that object capability.
yeah, we only need a public key of someone you want to give them your trust, right?
Yeah, but then the owner of that public key then only has the capabilities that you allow them to have, right? They don't have like full capabilities or anything.
Yeah. For example, I was thinking that in my application, I will ask you so generate me for me 100 key pairs and give me the public keys, and I will give you the 100 actions in my contract for these 100 public keys. So if I want to revoke it, I will just revoke it, and they will not work anymore. And each public key can only execute one action. So you just generate 100 keys, and you'll be use each keys for each key for one action, and that's it. So if you execute these 100 key pairs, they're gone.
Yeah.
Only you have this.
How do you revoke?
Yep.
I'm sorry.
I will keep map. I will keep map in my contract on all of these the public keys that you send to me. And I can also say for these public keys, I can give you these actions, for these public keys, these actions. I can specify everything. And I know that only your public key.
That's using access control, not capability. Right?
No, because I'm not saying that I'm giving this to you as a user. I'm giving this to this public key, which is generated. This is not identity of the user. It's just an object that holds some action in my contract. This public key doesn't have any meaning, or we can also go to unforgeable name, because you can protect unforgeable name with public key, so you don't have to generate all the public keys. I can give you unforgeable name.
A capability is an unforgeable name, right?
Yeah.
But
Wait.
for the same purpose, can be used the public key.
So Tomislav, are you saying that this public key that you would generate is kind of the object that you give capabilities to, like you give access to other users to use that public key, basically? Yeah. Exactly. Interesting. Okay.
Because very now it's very similar thing with OAuth protocol. So you have single sign-on, and Google gives you authentication token. Which has some capabilities that you can do. So,
I have very limited exposure. I've used OAuth one time for rclone, which is like rsync, I guess. I'm not very familiar with any of this stuff, but for like backing up, certain like file systems onto like Google Drive or something like that, you have to go through this OAuth process.
Yeah,
they generate a token for you and all this stuff.
Yeah, and in the background, you're really using OAuth everywhere.
Oh,
so when you log into Gmail, in the background, there is authentication token that the browser keeps, and execute all the actions.
Okay.
But it's not very granular. So now we want to have a very granular system. But when you can easily generate key pairs, and for each action you can define a public key or. So I see object capabilities very natural inside the rholang. I mean, you say what some unforgeable name holds or have a power to execute, you know.
Yeah, right.
You give to someone this unforgeable name and say, okay, with this unforgeable name, if you send it something on this unforgeable name, and only you can send, I will execute something. Or
Hmm.
I can give you access to my standard output because I listen to this unforgeable name and transfer everything to my standard output.
Oh, right. So are the bundles kind of just like another part of the capabilities story, or how do they kind of come into play?
Yeah, we definitely need bundles to say when you to protect, right, your
Yeah, like,
accessibility to, yeah,
yeah,
you give to someone a fungible name, but he can only write
yeah, or only read from it.
or only read, yeah.
Yeah. Mhm.
And you can check who execute something on this channel or yeah.
Yeah.
Yeah, and you can easily revoke it because if you listen on this channel and do some action, you can easily say, if something else not do anything or.
Mm. Yeah, I guess you could pretty well, I mean I'm not even sure how one would do this, but just like add some sort of list of like blocked users on a channel or something, and then just say like, any
Yeah,
messages from like this public key or whatever, just like forget about them.
yeah, yeah. And this really doesn't mean that you are blocking user. Maybe at the end you know you are blocking user, but you're
Mhm.
really blocking just this capability, right?
Yeah,
That you are
right.
assigned to this public key.
Yeah, yeah.
I think now maybe we can build some kind of web interface to create this kind of um, like the whole uh, the whole the whole all components for this art object to work without any special centralized server.
Mm.
If we start with only like smaller objects that are not that we can store on the chain. So,
So, uh, what do you guys want to do? Isaac? Thomas Love? I mean, I can start looking, uh, I mean, Gary and I can go on and start uh, bumbling our way through an initial art object.
Mm.
I don't think we're going to really have a chance to look at all. I mean, we're not going to look at all these interfaces at first in terms of how we handle identities, which is the 725 and 735. These are Ethereum identities. And this is important when we come to uh, uh, the DID, our decentralized identity directories. We have to have sort of a common interface,
Mhm.
anything that we're going to call an identity, right?
mm.
Um, we have to think about that sooner or later, as well as
And
the non-fungible token interface or the marketplace of these objects.
and these identities, you mean these are these hashes of the art objects, right? Like unique identifiers of the content.
Um, I'm not thinking about
I mean, we have some. We need to have some digital unique signature, right?
Mhm.
Yeah.
But I understand that these are also these are things already exist.
There's
So
an unforgeable name that is going to be generated when we create an art object, right? That'll be a unique identifier. Um,
but when you create an unforgeable name or you know you have some kind of key pair behind it who is owner who created this unforgeable name or you know
Yeah, I mean that's kind of the whole point of it, right? Is that only that key pair can access that unforgeable name.
Yeah, or multiple key pairs, right?
well,
Right,
the contract, doesn't have a key pair. I mean, it's a public key, but nobody has the private key, right? And when we're using capability model here, creating an art object, we're going to give it a certificate of authenticity. We're going to give it an owner. And I just for the heck of it, I gave it a percent here. In general, it could be any contract. I guess that's why we come up where we come up with the proxy. If we're making a specific a contract like the artist reserved rights transfer and sale agreement, if we, this is basically our first proof of concept is going to be implementing a subset of this contract.
So okay, I see. So the contract doesn't have like key pair related, but everyone who execute this contract or methods on this contract or anything related, he will be using this. He will be doing this using his private key. So in that case, when some art object author creates new art object, he wants to have control or part of the control, or he's not the same as all the others, right?
Yeah, and that's this owner.
So we have like a yeah. So we need to recognize this owner. This is where deployer ID is. How is it related?
Now, the owner can do anything, but he can create capabilities for anybody to do anything.
Yeah.
Mm-hmm.
And he will be doing this with his own private key, right?
Right.
So he needs to manage his private keys. I don't see how can you cannot avoid this part, right?
Well, the thing is, when the art object, already has the permissions of what we can do with it. So we don't ever have to use the private keys again.
But how can this author of this art object, for example, later decide to retract his rights or rights to some another owner, right? Because this is something that we want to do. I listened to Eric, and he was saying that this art owner can decide this later, right?
I couldn't remember. I didn't know which one it was, but I didn't want to take much about it.
Well, let me return an admin here.
Okay.
The admin is, I guess, the owner permissions. I don't know how to do this. I mean, capabilities.
Yeah, but capabilities is not the problem. You can share capabilities, but at the end, you only way you can interact with your own contact who is giving these capabilities. You will be doing this by proving your private key when you sign the deploy. So in this contract, you will compare deployer ID and your public key, and you will know, okay, this is the correct user who can execute and give this capability. So I see this very similar to how you transfer rep tokens. With your deploy and your private key, you are really proving that you are the deployer who can do this.
Mm.
So yeah, I agree that in art object smart contract, you don't have to work with exactly who is the deployer, but on some contract that accessing this art object contract, you will need to do this. You will need to recognize, okay, this is the owner, this is the valid public.
I mean, as I see it, whoever called this is going to get an admin capability back, right? And then there's going to be some capabilities that that can be created for okay, so we're going to create.
Did you mean this admin as a new variable, or the contract is a tuple?
It's a the admin is the returned administration capabilities. Okay, in other words, I mean, my point is here, we're not using, when we're using the capability model, we're not using private public keys anywhere. We're only using that initially to generate the item. And yes, there's cases where you have non-transferable ownership. If I buy a ticket and I sell it to you, it shouldn't matter. But there's other cases, but for airline flights, it does matter. In which case we have, we would need some kind of signature or something, a proof of identity. But generally, with the capability model, we don't care.
I mean, this proof of identity is moved to interaction with the network, right? So that all the other operations in the network, you don't have to take care of it.
What am I doing? And so I needed a new.
Admin is already defined as a parameter.
Yeah. I guess I'm thinking there's a public name and there's a private name, perhaps. Although I could use the same name, I could use just one name, and depending upon how I bundle it, it would give a capability or not. If I do a +0, it can't do anything, right? So it could be a name that has no power. Basically, if we within a VAT Mark Miller's model, we have the names are, if you know the name, you can do the thing. And that is, in essence, a namespace.
So, Jim, what's the goal with the code that you're trying to write right now? You're trying to recreate basically like a contract for a non-fungible token.
Yeah, you know, well, we're creating the resale agreement, right?
Resale agreement. Okay.
And the resale agreement says, well, I'm selling this to you, then you become the owner.
Yeah. Right.
Now you sell it to Gary.
Yeah.
Gary becomes the owner. You get a proceed from that, and I get a proceed of that, depending on the contract. Now, this contract is this particular contract is any increase in value, 15% of that goes back to me.
Okay.
Now, I don't know why. I don't know. But apparently, this is a standard contract.
So there would be some sort of royalties subcontract in this one you're building right now.
Right.
Yeah. Okay.
So, you know, I mean, it basically, the non-fungible token interface is just so that it can participate in standard marketplaces.
Yeah. Right.
So, you know, at this point, we're not too concerned with the standard, but we certainly want to keep that in mind, what the standard should be. And, you know, so let's see. So if I create an art object, I guess the question is, do I need, when somebody creates an art object, what we really want to pass here is a contract. What's the contract what's the contract, the resale contract?
Yeah.
Okay. And then we have to then define independently a resale contract. I guess let's do this properly, more or less. CW. Resale. Oh, right. Lower the insert. I hate when that happens.
And in this resale contract, you can encode any logic that you want, right? To transfer from one public key to another or anything else, right?
Yeah, maybe anything about the royalties and that sort of stuff.
Yeah, yeah. And you can give this contract to someone and say, okay, when you call this method on this contract, you will execute the action that I want. And that's it. That will be the end of this contract, right? Now,
Okay.
now someone else can do the same thing.
Now, I don't know what, whether we want something like, whether we need something like, we probably need something like a price here.
Well, maybe price. Maybe this will be encoded in the resale contract. So, you know, someone gives you this resale capability, right? So maybe you want to express the price inside because you are giving this capability. But maybe this can be just in this case.
So I'm creating an art, so that there's so the name of the contract could be confusing. Um,
So now this art object, the contract must create some unforgeable names that can give to the current owner, you know, after each resale, or this resale maybe creates these unforgeable names that can be given to the next owner, right? And and this unforgeable name will be supplied again. You know what I'm thinking. You create the first unforgeable name, then you create another, and then you say, okay, the first one doesn't is not valid anymore, so we have the next one. And
what am I doing? Better not that. Where am I? I don't understand what I just did. Oh, okay. So what I need to do here is in. This is not. Okay, so let's say we have a new buy, sell, uh, info. These are capabilities that the art object would have.
Mm-hmm. Jim, do you always code in Nano?
Nano?
Yeah, that's what you're using, right? Well, I mean, I guess maybe that's just the default text editor for the, because you're using the Linux subsystem, right?
Yeah. And I probably should move this over. What is this?
oh, this is Vim.
Oh, okay. It looks like Nano. I mean, I don't know the difference.
Yeah.
Okay, so I'm doing the .row here. Okay, so let's see. If I would have to install the highlighting there, but I can use. I should be able to use. Where am I? WD on Jim, and I should be able to use code, right? Art.row.
Yeah, and the code has special extension to start it in.
Yeah, I haven't tried it.
Yes.
The suggestion here is that for WSL you should run the visual code in. You run in the VSL terminal just as you would in a normal command prompt.
Yeah,
Okay,
but do
so
you have
I don't know why it wants me to do that, but
because now your current directory is connected to the virtual directory inside the VWCL.
so how do I do this? If I do the Explorer, open folder I have to hit.
Yeah,
Oh, what's that?
although you're not on the Windows.
Hey, this gives me the
Yeah.
the Unix version rather than the.
Yeah.
I'm running the Linux visual code
Oh.
rather than the Windows, and
Oh, that's interesting. Why did that open to the Unix subsystem? Just because you opened it there?
yeah.
Yeah, but Visual Studio gives this connection to other virtual file systems, so you can connect.
Oh.
The
You
suggestion
can be
here,
connected to remote.
the
Oh, that's
suggestion
cool.
here, I don't understand the suggestion. Maybe you can help me. To use VS Code with the Windows subsystem for Linux, please install VS Code in Windows, which I have,
Oh.
and install the Linux version in WSL, which I have.
Oh, it wants you to uninstall the Linux version in the subsystem.
Oh, it uninstall.
Yeah.
You can then use the Visual Studio Code command. What's the Visual Studio Code command?
Oh, the starting of the code. The code.
Just
So if
code like what you just typed.
Yeah, but
so if I type, I can uninstall code, but if I type code, it's still going to do it because I have it installed in Windows.
Yeah, but he will use the Windows version.
Uh-huh.
Inside the Linux, you can start some Windows programs.
You mean like I can
There's
do
like a strange
notepad?
mixture.
Oh,
Well,
that's
I'm not
I
saying
can do like
that.
a notepad.
Yeah, I'm not saying that everything will work, but something will work. But yeah, you cannot run any program, but some programs
Can you
are
give
working.
me an example? I mean, it seems really weird that it would run some Windows programs. But
So
maybe
maybe I can start.
I mean, I don't see how uninstalling the Linux version is going to help me, but I guess it says that's what it says to do, huh?
Yeah, I mean, my understanding of why it would help is because then it would be the right directory, but
Yeah,
I don't know.
Well, that's the other problem. In the Windows one, I don't even know how to get to this directory.
Yeah.
I don't know if I can get to it.
Yeah.
Okay, so this says no folder empty. You're suggesting that may be what the problem is. So I'm going to say okay.
First of all, you need to install extension on Visual Studio to work with WCL. So you probably have this extension, right? Can you look at this?
Okay, so now I open directory.
Yeah, and
so
as you said, you cannot directly open this directory inside the Linux, but you can, with this extension, you can like go to the bash and then open the directory.
No, I don't exactly understand why this is the wrong directory. Yeah.
But can you check if you have this extension?
What extension?
Extension for VWCL on Visual Studio. You need to have this extension. It will not work without it.
Yeah, that's what will give you the capability to do the R-Node eval.
Sorry?
Oh, no, I was just saying that's what will give them the capability to do the R-Node eval.
What happened to my?
Sure.
What happened to my? Is this? Is there another window open or something? That's weird. I mean, here I can't find the file, right? What it opened here is not the file. Is not my file system that I'm in.
But this can be your VWCS home directory or something.
Mm-hmm.
Not the Windows, but the Linux, right?
Yeah, I think that's right, because all these files are the same as when you open the folder and
okay, I do
the
have
graphical thing.
I don't know why I couldn't find R.row.
Yeah.
Okay, so we're fine. Sorry, thought it was someplace.
Okay.
I thought it was someplace else. So this is working fine. I guess I could try deleting visual code in Linux and
Mm.
see if it makes a difference. See if it works. I'm not
And
sure
you can also use this with the Docker or some remote SSH server. So you can connect to robot and open folder directly on your robot server.
How do I do that?
So I'm using, this is not part of this extension, although Microsoft is planning to do this with any remote server, but I'm especially using, sorry, must check. Remote SSHFS. I can send a link.
Is it?
This is the one. Where's my Zoom? No. I'm using this extension to connect to my remote servers, and and this works pretty great. I open the remote. I have SSH setup with like, and it's working better on Linux. I have my SSH connections with certificates and private keys. Yeah, but you need to search this extension is inside the Visual Studio, SSHFS.
Okay, so here, if
Yeah.
I go to
On the last one, at the bottom. Yeah, yeah.
I can do
SSH FS. Oh yeah, it's the second one. And you see that this is the Microsoft Remote SSH. So I didn't try it because before it does not exist, but yeah. And then you will have your list of servers, and you just click connect and
use the command SSH.
yeah, you create different connections and you enter your login info. You can use a certificate. You can use a password.